the last video, we have seen and applied the conservation of charge for any junction points. Now, let us try to apply the energy conservation for any circuits. You can understand this law or the conservation of energy similarly like roller coaster. As you will notice, in roller coaster, you will go to the up heights while gaining the potential energy and come down while converting that potential energy into kinetic energy. It doesn't matter how much loop-de-loops you will go through. Every time you will start and end at the same point with same energy levels. This will gonna happen with any electron in any circuit as well. Kirchhoff applied the energy conservation for a simple circuit and gave us his law. Let's try to understand it. First, see here. What I have a circuit here. This we call as a simple electrical circuit. What it means? It means that we have certain electrical elements connected together with the help of conductors. Here you can see we have two cells with potential or EMF V1 and V2. We also have some resistances R1, R2. In a loop, there is a current flowing. You can let the current in any direction while applying this law. If the direction will come in the negative answer, what it means? It means the direction that you let was absolutely wrong. Let us try to understand it. What I'll do, I already let a direction of the current, let's say I. Only one current will flow as it's a one circuit and connected together. Now, in a current, try to understand it as an electron. Means you are an electron and you are traveling within a circuit. While traveling, you will lose your energy whenever there is a resistor, and you will gain energy whenever there is a cell or a battery, because that what these two elements will there for. Now, while applying this loop law, I just have to take any direction. So while taking a direction, I am taking the direction as you can see here as an clockwise direction. I'll write it here, clockwise direction. While moving, the first thing come is V1. So if I were an electron, then while going through this cell V1, what will gonna happen? I'll lose my energy. While I lose my energy, because I'm going through positive plate to the negative plate. Thus, I'll write it as a negative because I'm losing my energy. So I'll write minus V1. Now, what will come? Here, it will come R1. So, R1 is a resistance and I'm going through it within a direction of electric current, because this is the direction of electric current. I'm moving in the direction of electric current. So, while moving in the direction of electric current, I'll also lose some more energy going through a resistor. How we define that energy? If you recall from Ohm's law, we have V equals to IR. This V is nothing but the electrical potential energy. That is, I have written here V1. And while going through a resistor, I'll lose the energy IR. We have the current I and we have the resistance given R1. So I'll write minus I R1 is the loss of current energy. Now, when I come here, what will happen? Again, one more cell will come. What it means? Here, if you will notice, I am going through negative terminal to the positive terminal. Means this cell will do work on me and give me some energy. Let's try to understand. While gaining the energy, I'll gain the energy of V2. So I'll write it as plus V2. Now again, I am going through a resistance within the direction of current. This is the direction of current. I'm moving through the resistance within the direction. So what I'll write? I'll write again the loss of energy minus I R2. Now there is no more element in this circuit. We have covered all the things. I just have to equate it with 0 and we'll get V2 is equals to IR1 plus IR2 plus V1 plus V1. As you can see here, if you know all the external elements, that is the EMF or the electromotive force of both the batteries or cells that are V1 and V2, if you know the external resistances R1 and R2, you can simply find the amount of current flowing in this circuit. I hope you understood the concept. This is what Kirchhoff's loop law or Kirchhoff's voltage law is. Now let us try to apply the same logic in a circuit. Here I have a circuit here with two loops. We have to take any loop one by one. Let's start with the first loop. Let's take the first loop, that is A, B, F, A, B, E and F. This loop A, B and F. We let the direction of current completely random, I1, I3 and I2. Again, keep it in mind that we cannot let it randomly. Like if I1 is coming in, I2 and I3 need to be go out, means all three should not go out and all three should not come in. Now, let us again take this direction clockwise. So I'll move in this direction and I'll think that I am a charge. So let's say I'll start from F. I'll go up. In this, I have a current I. Why? Because the conductor is directly connected. So here we also have I1. Here we have I2. And here, I don't know. We have, let's say, I1 only because it's connected thrice. So here we have I1 in these three conductors. In these three conductors, we have I1 and here we have I2. Let's write it out. While moving in this direction, what I'll do? I'll gain the energy by 2 volt. Let's write it out here, plus 2. Again, in the direction of current, when we go through a resistor, we lose the energy. How much we lose? We lose minus I1 multiplied by 4. Following the Ohm's law, V equals to IR. This is the 4 ohm resistance. We reach to the point B and then we are going down. Here the current is I2 and while going down, we go through a voltmeter. While going down, we go through a cell that is of the 4 volt. What I can write? I can write that I'll be gaining the 4 volt energy. And then again, I'll go through this 2 ohm resistor. Again, within the direction of current, so I'm losing certain amount of energy that I'll be calling is as I1 multiplied by 2 equals to 0. Now, here we get a simple equation with one variable, that is I1. I can simply solve it out and generate an answer. Let us try. What we'll get? 4 plus 2, 6 equals to 4I1, 2I2, we'll get 6I1, 4I1 plus 6I1, we'll get 6I1, okay. And then solving it a little, we'll simply get I1 equals to 1 ampere. I hope you understood that how we can apply the Kirchhoff's voltage law or the root law to get the value of the current. Now, let us try to apply the same for this second loop, this loop. What I can write for the second loop, that is B, C, D, E. What I'll get? Let's try. We can start from any point. Let's start with B. While starting from B, the current is I3 here. So current I3, I'll go through the resistor that is of 2 ohm. I'll lose the energy. Why I lose? Because I'm moving in the direction of the current. So I'll write minus I3 multiplied by this resistor, that is 2 ohm. Now again, I come against a battery or a cell. Here I am moving from positive terminal to the negative terminal. Means what I am doing? I am losing certain amount of energy that is already given here as an EMF of this cell is 6 volt. So I'll write again minus 6. Now same current I3, here is also I3. In the direction of current, how much resistance I have? I have 4 ohm resistance. Means again I lose the energy, that is 4 ohm multiplied by current, that is I3. When I come here, I am again going from positive terminal to negative terminal. Means I'll again lose the energy. And how much I lose this time? I lose the 4 volt. Let's write it out here. Minus 4 volt equals to 0. Solving this equation, what I'll get? Let us try to solve. I'll get minus 4 plus 2, 6I3 is equals to 6 plus 4, 10. I3, I'll get 10 by 6, that too in negative direction, ampere. Now, I have the value of I3 but in negative direction. What it means? It means that the value of the I3 that I let here is not in this direction. It's actually in its opposite direction. Now, let's apply the junction law, Kirchhoff junction law at point B to get the value of this I2. Let us try to do that because we did in the previous video. So for the junction point B, I3 is coming in, I1 is coming in, I2 is the only which one going out. So what I can write? I can write like for junction B, applying Kirchhoff's current law, KCL, what we'll get? We'll get I3 plus I1 is equals to I2. I3 plus I1 is equals to I2. We know the value of I3, that is 10 by 6. Why I am not taking the negative sign? Because I already changed the direction. So I get 10 by 6 plus I1 is nothing 1. As we have calculated here, I1 is 1 equals to I2. I2 will get 6, we'll get here 16 by 6 ampere. I hope you understood that how we can apply the energy conservation, that is Kirchhoff's loop law, in any circuit. That's all for this video. In the next coming sections, we'll understand more about the electrical circuits and the combination of multiple resistances and the cells. Till then, keep learning and keep exploring with Tutorac.